Greetings, I am Amarnath Murugan and I'll be presenting a work in progress paper titled Towards Avatars for Remote Communication using Mobile Augmented Reality. Social AR and VR are considered to be the future of remote communication and social media. They allow for similar spatial dynamics as that of real world co located meetings. While head mounted displays provide richer interactions and higher presence in the social spaces, they are relatively more expensive and difficult to access, which is why we believe mobile social AR could be a viable and cheaper alternative. The major challenge in avatar representation for mobile social AR is that we just have a single point of reference, that is the handheld device's translation and orientation, to estimate the pose and movement of the person holding it. There's also the consideration of should we represent the avatar as a person itself, or do we somehow imply that the avatar is a device held by a person. The broader goal of the study is to identify the possible avatars in the space and to measure their social presence. That is, to understand the extent to which we believe that the other person is in a shared space with us. Another goal of the study is to see if multiple different avatars are better suited to different contexts, or do we just have one avatar that works across all the different activities. Prior research has shown that increasing body part visibility increases the social presence of these avatars, and also increased tracking fidelity also increases social presence. But there have been cases where users have preferred floating heads and hands over inverse kinematics based inferred avatars because they have an expectation of more behavioral fidelity from these inverse kinematics avatars, which wasn't met. Accounting for this, we have established an avatar space that varies in two dimensions, which is movement and body part visibility. In the case of movement, we have two options, direct and inferred. In direct avatars, just use the translation and rotation of the phone as is. In the case of inferred avatars, we try to estimate the pose and the movement of the person from that single point of information. Body part visibility is chosen as another dimension because it affects the type of movement that is required. For example, it may suffice to use direct movement for hands avatar, but will require inferred movement for the full body avatar. From the 14 possibilities, we choose 5 avatars that might give us unique insights. The first is direct hands. This would act as a baseline against which the other avatars are compared. In direct upper body, we apply the transformations of the phone onto the torso 3D model, so it may seem like the apparent movement of a person instead of the phone. In inferred upper body plus hands, we infer the movement of the user through the movement of the phone. To the previous avatar, we add inverse kinematics based arms and see how that stacks up as well. And finally, we use the phone's movement and orientation to infer the pose and movement of a full body avatar. While it may not be possible to accurately predict the pose of a user, we are trying to see if this could be used to increase social presence without confusing the intentions of the user. To infer the movement of the user from the phone, that is to infer the root motion, we first start out by calibrating the avatar's arm reach and height through the user's interactions with the AR environment. For more details on how this is done, please refer to our paper. To determine when the user has moved from their current position, we use certain criteria that are based on a single heuristic. That is, the user tends to hold the phone at a comfortable viewing distance in front of them. So when we notice that the avatar's arm is overextended or underextended, we move the avatar. Similarly, when the phone deviates from the center, we again move the avatar. The same goes for when the phone's orientation goes beyond certain limits. To get responsive body movement, we use inverse kinematics from Unity's animation rigging package to move the arms and head. To change the pose of the avatar and to get walk cycles and crouching movement, we use blend trees to blend between different keyframed animations. The animation and model were taken from Mixamo. We propose a 5x2 within subject study where the independent variables are the 5 avatar types and 2 types of tasks. The dependent variables are social presence, which is measured through the network's mind and social presence scale questionnaires, and unstructured qualitative feedback. First, we have the social task. This has three main criteria. The first is we need the users to focus on the avatars of the other user, and the task should foster one-on-one and one-on-many discussions. In each session, we have groups of 5 as opposed to dyads because the previous studies are focused on dyads primarily. We use 20 questions as a social task. So each person gets a word which has to be guessed by the other 4. So there is one-on-one discussions when one of the 4 asks a question to the selected user, and there is one-on-many discussions when the 4 users try to determine which question should be asked. Artifact-centric task is similar to the planning work done in meetings. This has 2 criteria again, which is there should be frequent context switching between the artifact and the avatars, and the task should nudge the users to walk around in the AR space. We do this through a comparison tasks. So we instantiate 2 3D models in the AR environment, and we ask the users to compare these 2 3D models and come to a consensus on which colors are missing. Finally, we are working towards completely procedural avatars, which wouldn't require keyframed animations, and also we are looking into deep learning based models that would generate the complete pose for the full body avatar. Thank you. If you have further questions, please reach out to us.